An easier way to understand is our average when we look at both of them.
Yeah.
Are we going above that max temperature where we are going to start seeing the negative effects? So for most crops, for example, for corn, we haven't gone beyond that range. Once we hit that, yes. And that's why the idea is to stay in front of it and look at, because I'm corn agronomy, to start testing some of the ways we can counteract it. When it comes to most of the temperature, when you have irrigation, make sure you apply that irrigation at reproductive stage.
Welcome to the Crop Science Podcast Show. My name is Brian Ernell, and I'm coming to you from the Oklahoma State University campus. And this show is proudly brought to you on behalf of Wise Genetics. Today, I'm excited to have a scientist who I've known for pretty much his entire scientific career, you might say, Dr. Jagmandeep Dhillon. We call him Jagman down here at Oklahoma State University, but he's the assistant professor and corn agronomist at Mississippi State University. And I know Jagman all through his graduate school, as his major advisor was my major advisor, and I got to work with him closely as I was the extension arm of Dr. Ron's research arm. And with that, I welcome Jagman to the Crop Science Podcast. Jagman, before we get into your research, which I'm really excited to hear about, tell us a little bit of how you ended up, not just at Mississippi State, but your route through Oklahoma State, because we got to throw a little Go Pokes in on this.
Oh, yeah. Thank you, Dr. Ernell, and I appreciate you inviting me on this podcast. I'll go briefly on my background. I was raised on a wheat rice farm in northern India in state of Punjab. And I was always fascinated with machinery, agriculture, and that kind of pushed me to get a degree in ag. So my undergrad is in bachelor's in agricultural engineering. And after that, I got a chance to work for CIMMYT. So I was a CIMMYT employee for 2.5 years, and I ended up using GreenSeeker. And I ended up Googling GreenSeeker for first time, maybe 2011-12. And NUE popped up, the okstate.nue, the website Dr. Ron had. Ended up reading stuff, knowing a little bit more about GreenSeeker. I had no clue what data I was collecting and how it is going to be used, because that was probably one of the GreenSeekers sent down to India, maybe. And then looking into it, I was more fascinated with agronomics, with precision ag. I kind of impressed my boss back then, who knew Dr. Ron, and he made that connection. I let him know that I want to pursue further education, and this is the road I want to go down. And since Dr. Ron worked for 7 years, I think, or 9 years, I might be mistaken, before moving back to Oklahoma State. So knowing that they had the connection, he introduced me to him. And luckily, there was a place available for a master's student. And that's how I ended up coming to OSU back in 2014 for my master's. And I stayed there for my PhD as well. I was so glad to have you on my committee. It was fun. It was challenging. The best memories I have are my thesis defense for my master and my PhD defense. I think those were the best things I remember, because when you get thrown around in the room and try to figure your way out of it. So that was fun. And I finished in December of 2019. And I started interviewing for assistant professor positions, because I wanted to get directly into it, knowing that I had worked before and I had a little bit more experience. I thought I can go and do this. So I interviewed around, and out of all the offers I had, Mississippi State was something that I would have wanted. It has a research and teaching component, and I thought I can do teaching, and that's how I ended up at Mississippi State, and I'm running the Corn Agronomics program.
So that's awesome. I really enjoyed. Not too many folks will say that their happiest memories was in their thesis dissertation defense. I'm just going to be honest. There's usually a lot of strife and anxiety. But moving on, now that you've been down there and you're kind of settled into that environment at Mississippi State, what's some of the work that you and your team have been doing lately?
That's a good question. Being early career, I didn't want it to go just specifically into one side of things or one area of research. My background being in precision nutrient management, and I am continuing some of that work. So we are looking into ways to improve the way we manage our nutrients, especially nitrogen. So some of the things that Oklahoma is known for, the sensor-based program. So I'm trying to do similar things, trying to come up with models and algorithms for mid-season nitrogen management, and that work is kind of slow and continuing depending on the funding and research. But again, I didn't want it to be narrow on my focus, so uh, I wanted to a little bit go out. So some of our research, we are looking at climate change, knowing that as early career, you cannot just rely on field data. It's not that you have to wait for 2 years for a student to graduate and then you do come up with publications. So we looked at all the data that we had available, and we used some of that data to look, okay, how last 30 years of weather fluctuation and how that is affecting the crops in, of course, corn and some of other crops in southern U.S. So we came up with some publications looking at, okay, how T-min is affecting, or T-max, because we have mainly focused on average temperatures, but we haven't gone beyond it. So we ended up looking more discreetly and separating those two. And what we found was, like, of course, when we think about climate change, we think, oh, it's going to negatively affect yield, but that's not true at all the locations, and that's not true in all the months. Okay, like some months, like for example, reproductive stages. If your temperature is high during those stages, of course you're going to have negative effects. But then T max and T min are going to have separate effects. So we ended up finding so far, as of where we are now, because our average temperature for most of our crops are not beyond that high temperature where we'll start a negative yield effect, we are still good to go. With one crop, wheat is gonna get negatively. We are gonna see some negative yields when it comes to southern U.S. But corn, soybean, cotton, they are all still good as far as we are concerned with weather and looking at increase in or changing climate.
So talk to us a little bit about what you've seen. Let's not look at the crop just yet. Let's talk a little bit about what you've seen in the weather data. As you discussed, we typically think about the average daily temperature, the average weekly. We look at this average, but you're absolutely right. Average is a combination of a min and a max divided by 2. So what's a low, what's a high? That's at T min, T max. So what are you seeing as relationship A, just to the average in your region, and that T min, T max versus 30 years ago?
Yeah, that's a fantastic question. Looking at all, let's start with T max and T min. Every decade we have seen an increase in both of them. Okay, and even precipitation has been increasing.
When you say an increase in T min, is that increase in a lower temperature, or that the T min is rising?
So lower temperature. So as you mentioned, we usually look at.
Yeah.
Yes. So I could give you a number, but I could be off. I should have remembered this.
That's good.
But both T min and T max, we looked at per year increase. They are increasing. But and we also look at something called diurnal temperature range, and DTR, which combines both, which is actually going down because of the way it is calculated and because T-min and T-min is increasing. Now, what we did found was, like, if we separate their effect, T maximum effect on most of the crop is always negative. T-min's effect has been positive. So they offset each other. Okay. So all together, when we look at them all together, we are still coming up on the positive side for most crops. And similarly, we also look at carbon dioxide emissions. And considering some of the crops, that is also giving us a positive yield. So altogether on most crops, again, because we have looked at multiple crops. And before I forget, I need to give a shout out to my PhD student who led this project. So this is all his project. So I was glad to have him and have him run this. So I didn't want it to go towards this field as quickly as I did, but when I saw that my student was really committed, I thought, okay, this is something I was gonna do, so we will do it. And yeah.
So I'll get to the other crops later because everybody cares more about them than I do. But the wheat. So you mentioned that wheat was the one that you see more potential for negative in the southeast region. Is that due to what is that due to? Is it due to temps during flowering? Is it due to winter survival? Where are you looking at in that negative effect on the winter wheat?
So we okay, for wheat itself, we didn't separate it out at that discreetly.
Okay.
We started working on each crop specifically. When we worked on wheat, we looked at a whole of the 11 state in southern US. And overall, what we found was, again, increase in Tmax and increase in Tmin because of the timing when we are planting and timing we are harvesting. Both are negatively harming it. So that's why the overall effect was, if I remember correctly, it was not significant when we talks about statistics, but numerically it's going to be negative.
That's interesting. So a broader range, basically colder colds and hotter hots, or at least hitting the wheat potentially harder within the region. And I can kind of see that. Now, can you kind of hypothesize what that is? I mean, is there any, as you look at the data, as you're more familiar with it, can you kind of postulate a little bit, or is it really just too broad of an answer?
I think it's going to be too broad of an answer. Okay. The reason being, we are talking in this, all the 11 states.
Yep. Okay.
We started, if I was in one state, even within one state, you are going to see trends as you go from south to north. That's why sometimes I would want to not go into it and that much to give you enough answer.
That's fair enough. Okay. But specifically your summer crops, not seeing significant, basically what you said was, if I reiterate right, that since the lows are getting lower, they're slightly offsetting the highs getting hotter.
Actually, the lows are getting higher too.
Okay, so your minimum is okay. That's what I wasn't 100% sure on the conversation. So your lower temps are coming up.
Lower temps are coming up too.
Okay,
but the reason is, again, in an easier way to understand is our average when we look at both of them.
Yeah,
are we going above that max temperature where we are going to start seeing the negative effects? So for most crops, for example, for corn, we haven't gone beyond that range. Once we hit that, yes. And that's why the idea is to stay in front of it and look at, because I'm corn agronomy, to start testing some of the ways we can counteract it. When it comes to most of the temperature, when you have irrigation, make sure you apply that irrigation at reproductive stage, because we looked into individual months when these changes are gonna really hit hard, and it's always around that reproductive stage.
Yep.
And the possibility of having irrigation, applying it at right time, can help with that. And then also hybrids and all that kind of stuff can also help.
Okay. So as you look at it, we look at that average. Is the indication or any look that the range between low and high is changing? Because as you say, the average is going up, your min is going up, your max is going up. Is the variance or the difference between low and high changing much, or is that staying fairly consistent?
No, it's unsymmetric. Tmin is increasing much faster than Tmax is.
Oh, okay.
Yeah, so the minimum temperature is increasing much at my higher phase in any of the crop. If you focus on any of the crops, that's what we have noticed consistent.
That's fascinating. Well, Crop Science Podcast Show, folks, we're happy to have with us today Dr. Jagmandeep Dhillon. He's an assistant professor and corn agronomist at Mississippi State University, and we've been discussing his recent work looking at climate change influence on crop growth throughout the Southeast. And we're going to now transition in the last half of our conversation. Jagman, I want to talk about precision ag, some of the work that you're doing, talking about the nutrient management side of corn. First, what are some of your, I guess I'll go this way. I'll just throw it out first and let you run with it. What are some of your wins and what are some of your challenges implementing this technology throughout Mississippi?
No, I should have started with that because I'm a little bit more comfortable with that. So initially, when I started this position, I had two basic questions which I wanted to start with. The first was what is the yield gap? Where are we at? And that answer was the question was simple, the answer wasn't. So we ended up looking at, and what we used the yield contest, corn, the National Corn Grower Association, they run this yield contest every year at different states. So we had that data, and then Mississippi Extension does a good job, and they test all the newer hybrids at 10 to 15 locations across the state under irrigated and dryland conditions. So we had those data available, and then we had the USDA NAS data available. So what we thought was, okay, USDA NAS is going to be our actual data, and all the others are going to be our different yield potential. If I can irrigate, or yield contest is going to be my maximum yield potential we could reach. And what we found was, and we just focused on last 10 years, considering that the hybrids rotate pretty quickly. What we found was we are still looking at a 2 to 5 megagram per hectare yield gap. So there is a significant yield gap. Then the next question was, okay, now let's get into the nitty gritty. And the other question was, okay, we're still, for nitrogen recommendation for corn, we're still recommending the yield goal algorithm. And we wanted to look at, okay, how off can I be, or how accurate that is to begin with. I didn't want to start with saying that it's a bad thing. It's not going to be accurate. So we ended up running variable N rate trials, going so that we have the range, so that we can calculate an agronomic optimum N rate. And we ended up comparing if I would have recommended with a yield goal versus what my actual optimum is, we are always off. On average, we are very close, but in specific year, I can be as off as 150 kilogram nitrogen. And that goes both ways. You can be above and you can be below. And of course, we know the limitations of yield goal algorithm. It doesn't consider spatial variability, temporal variability. It has some basic assumptions, which is go by. So that kind of gave us a platform. Now we know we have a yield gap, which we are not even talking about changing the hybrids. It's within the same hybrids we have big yield gap, and now we know that the way we are recommending nitrogen is not as good as we want it to be, and that kind of gives you okay, what are the alternatives, and specifically targeting nitrogen. Coming from Oklahoma, of course, sensor-based is something that we want to do. Now, within this, I kind of had to go back and poke some holes into the algorithms we had at OSU. We only use one VI, which is usually NDVI, which works well for wheat. But when you want to use the same for corn, it doesn't do enough, as good of a job as some of the other vegetation indices could do. So we started looking at different vegetation indices. We also started looking at, okay, if I have a cover crop situation versus what kind of history of fertility I have on the field, does that throw off my vegetation index, which it did. So for each specific location, of course, this is not at the application stage yet. This is still at research stage, where we are trying to see, okay, which vegetation index would work for which condition. So I'm talking about site-specific models, and those models are going to be specific based on the cropping history as well. And then, of course, with the way the data management and data processing and data analysis is moving with machine learning and all that, we wanted to combine a lot of information. If you run a multispectral sensor, you are looking at 5 bands, and you can end up with combination and permutation and combination, come up with different combinations. And you need to use machine learning to figure some of that out. So I am still not at that application stage. I don't have anything to recommend to a producer, but I can tell that we have figured out that there are some stages where we can do a better job at recommending nitrogen rate. Like I can come up with a good prediction. And then we found which vegetation indices work better. And then something on the research side alone, I'm going a little bit further into this. We wanted to look at explainable machine learning. Because when we use machine learning, we put everything inside a black box where I know I have a model which works well, but I cannot explain why it is working well. So we wanted to look at, okay, can we? And again, I have to give a shout out to my postdoc that I had. He left me because I couldn't support him further, but we are still working together. But he having his background, we were able to figure out, okay, what and why some of the algorithms work better when it comes to machine learning algorithm, because they can touch all of that data points, which were very highly variable. And because I can touch it, that's why I can make good recommendation. So I'll leave it at there unless you have other questions.
No, that's fascinating. What kind of growth stages are you finding success at? How early can you go?
Now that is the $1 million question when it comes to corn. And as you know, corn doesn't give something away as early as it should. At reproductive stage, I can give you a perfect recommendation.
Absolutely, in all crops. If we could wait till it's reproductive, that is a game changer.
It is, and it's in Mississippi, some producer does make a test switch crop. We can come up with a very good recommendation for that. But we wanted to, again, the question is early because V6, that is the stage when everyone is making a lot of side dress application. I can come up with good, there are vegetation indices such as SCCI, which combines both NDVI and NDRE. In other ways of looking at it, it combines both the changes in biomass, which is your NDVI, and NDRA's changes in chlorophyll, which doesn't start happening visibly. But if I combine both of them, we can predict that yield potential at V6.
Well, that makes a lot of sense because historically I've always talked about the NDVI is good when the plants are small because it's extremely sensitive biomass. In fact, soil background is critical to help NDVI separate out that. And NDRE, the red edge, it really starts separating out once we have fuller canopy coverage because it is more sensitive. So it makes perfect sense, really pulling those two together into an indice. Some of the challenges I'd foresee is actually, where are we getting the data from, which is something, if we get something good, then we can create it. But there are challenges accessing usable data, correct?
It is. And I'm glad you mentioned the data platform. Let's call it platform. What are you using? Are you using a proximal sensor? You're using a UAV, you're using satellite, all of those are going to make a difference, and those are not interchangeable. We had a research where we looked at, okay, can I use something that I'm predicting using a proximal sensor and say use a multiple spectral and see if I can interchange those? It doesn't work. So if in future you are going to make an algorithm, even if it is same VIs, you have to stay within that platform to make recommendation as well. And it is definitely right. NDVI being the simple index, it still has its value, especially early season when we are looking at biomass and we want to look at some of that soil. And actually, in one of the research, we did focus, okay, there are SCCI work. I think we're just going back into what we talked about. So yeah, there are VIs that works really well. And yes, you have to be really, you have to pay attention to the platform you have used to come up with this data.
It's funny. It's something we've always go back to kind of as we'll wrap up is that, if you look at the history of research and looking at VIs, the search for a VI, the vegetative indice that is good for nitrogen or yield, it's not new. In fact, we've been searching vegetative indices since the mid 90s. And what it comes up to is that and simply, or at least what I could say from my summation is there is always a best case VI for a certain location, but to get one that is uniform is almost chasing that unicorn because there's so many different variables that play in. And so getting in these conversations, sometimes you can't go with the always best. You go with the one that's the least worst.
Yeah.
And so it's a fascinating concept with this. Jagman, I think we could sit here and talk for another half an hour easily about what you're doing. And so that means we need to have you back on. But, I thank you for coming on. So listeners, again, this is Dr. Jagmandeep Dhillon. He is the assistant professor, corn agronomist at Mississippi State University. We greatly appreciate you coming on. So let's wrap up in our questions.
It's time for our famous three. Explore the future of agriculture with KWS, a global leader in innovation and sustainable farming practices. Uncover the exceptional qualities of our hybrid rye, cultivating a legacy for a greener tomorrow. Visit kws.com/US for more information and for dealer locations. KWS, seeding the future since 1856.
Jagman, where do you go for a good work resource?
Oh, yeah. Yes, good work resource is really important. Like sometimes you're in a time bind and you need information quickly. I have Google Scholar or talking to my colleagues. I'd rather knock on someone's door and ask them and pick their mind. Lately, now that we are in the world of AI, I've been using some tools, and it's fascinating that what they can do. But again, the way I'm trained, you never rely on one source. It's always good to look up. So I've been using Copilot, which is free, I think, for most universities. It's sometimes really good to, I think, in this era, it's important you ask a good question so that AI can help you. Because it's going to feed off of you how accurate you are into asking what you're asking.
Yep.
So in short, first I'll go to a colleague, pose them a question. If they cannot help me, then I'll go to Google Scholar, look for a paper and something like that. And then AI, because it can put everything together sometime. Yeah.
So I always feel bad about asking this to new profs that are out there trying to work and get tenure. But what's your favorite leisurely activity, Jagman?
Yes, I'm a new parent. Our son is almost 2, so spending time with him is now, I guess that could be leisure. He's very into books, so reading books with him and stuff like that. And before that, I used to enjoy watching TV and shows and stuff like that. I don't get to do that as often. But it's not bad. Yeah, I'm not complaining.
And finally, where do people, if somebody wants to know more about the Dhillon program, your research program, where do they go to find more information?
The easier one would be to go to the Mississippi State Plant and Soil Science website, and there are web pages for each faculty. I also have a lab page, which can be found actually on my Twitter. I would say semi-active on Twitter. I tweet about most of the work stuff, but that is the only social media platform where I'm most active. And I would tweet quite frequently. So that would be the source. I'm on LinkedIn. I have never figured out how to use it. And I am there, but Twitter would be the best place. Yeah.
Fantastic. Well, Jagman, thank you so much for joining us today. I always enjoy visiting with you and finding about what you're doing. Folks out there in the World Wide Web, make sure you subscribe to the channel. Let us know that you like what we're doing and share it with your friends. And as I say, even if those that you're just somewhat comfortable with, make sure everybody knows about what's going on in the world of crop science. If you have questions, if you have comments, make sure you let us know those. And if you have any suggestions for our next guest, hit us up and let us know. Jagman, thank you so much.
Thank you. Thank you for having me.